Independent sample t-test. It has various names for the independent sample t-test. Like someone will tell t-test, some will tell student t-test. So there are various names, but the names are different. But so the test is same. In t-test, it is very commonly called. It is t-test. Another is called paired t-test. Okay, so this is the version of the t-test only, but some assumption on nature of the data differ that we will be discussing when we do the pair t-test. And after that, we will go cover the ANOVA and the repeated measure of the ANOVA. These are the commonly used parametric tests what we are using in our day-to-day practice. So before going to the test directly, I will give you some brief overview about the p-value. What is the p-value? I hope all of you know what are the cutoffs and when we say statistically significant, I know, but let us get some brief glance about what is p-value. So P stand for the probability value. Can we suggest that the difference that we observe is by chance or a true difference? So what difference we are expecting that is happening only due to the chance or beyond the chance? That is the thing we can able to know using the P value. P stand for the probability. So what are the probability? So suppose two persons are meeting in a cafeteria for 2 days. Any participant want to tell whether this thing can happen in your life day-to-day practice? It may be due to the chance or it can be beyond the chance. What any participants want to tell for this? You can write in the chat box also. SPSS, someone has written that workshop was about the SPSS. SPSS is not freely available software. So it is more or less similar to the SPSS. No need to write any command. Jamovi is very user-friendly software than the what we can say SPSS. More simpler than the SPSS and freely available. That's why I have taken this one, and it will take less time also to analyze the data. That's why I covered it. So hopefully you will enjoy it. Please download it. It is freely available. Okay, there is not at all any problem in using this software. So. So most of the people, what you are writing, that can be due to the chance. Yes, we often see our daily practice, two person can meet in a cafeteria by chance. So meeting in a cafeteria for 3 days, maybe you will say yes, that could be also possible due to the chance. Suppose evening time they are completing their work at the same time, they can meet. But what do you think? If they are meeting in a cafeteria for 5 consecutive days consistently, then what do you think? It is by chance or beyond the chance? You can write in the chat box. It is the chance or beyond the chance? Most of you are writing beyond the chance, means they have already communicated that key they have to meet in this particular time in a cafeteria. They have already WhatsApp them. WhatsApp is very user-friendly software now. Yes, so they have planned. So these things are happening beyond the chance. So remember, so p-value will tell you things are happening by chance or beyond the chance. Okay. So let us come with some probability example. Okay. So null hypothesis for any, whenever we test our hypothesis, okay, or whenever we analyze our data, we want to know the two groups are similar or not, or one group is better than other or not. So p-value for any statistical test, there is one hypothesis which is called null hypothesis and which tell us groups are similar. There is no any difference between the two groups. And there is alternative hypothesis when we reject this null hypothesis, when things are happening beyond the chance. If it is happening due to the chance, it will be fall under the coverage of the null hypothesis. But the things are happening beyond the chance, then also we will say null hypothesis rejected and there are true difference. The probability for true difference we can say. So significant if the p-value is less than 5%, that is the common cutoff. We also know, everyone knows. So 0.05, whenever you do the hypothesis testing and the p-value is less than 0.05, you will say statistically significant difference. So now you see this is the cutoff. I hope all of you know this thing. So now why this cutoff has come? Okay, so many one the doubt will come to your mind. Why it is less than 5%, isn't it? So many one will feel that. So let us know why it is 5%. Suppose the five friends, this is the story. Okay, so you have to tell me what do you think in this case. Five friends, okay, so they are just met together. The names of the friend in terms of A, B, C, D, and E. Okay, so this is the name. So they gather to decide who will get a free dinner tonight. Okay, so they have just planned, and what the approach they have used? Tossing the coin. Okay, the everybody is given a similar coin. So coin is same and asked to toss it and stopping when they get the tail. So question is very clear. Suppose I am tossing it. How much head I will get? I will continue. Okay, and once I get the tail, I will stop. So that is the number will end. Okay. So whosoever got the highest number of the heads before getting a tail will get a free dinner tonight. So the highest number, the more number of the tails will come, then that person will get the free dinner. So all will have so contribute their money, and that who got the highest number of the head will get the free dinner tonight. So now I want to know from the participant. Suppose A got first head and after that tail. So what is the probability for getting one head? What is the probability? Suppose we toss the coin and we just got head after the tail. So what is the probability? Or in the simpler term, suppose we toss a coin, what is 50-50%? Yes. So once we toss the coin, there are 50% probability that we will get the head or we can get the tail. Okay, so one person, how many head he got? He got one head after the tail. So it is stopped. So what is the probability? 1 by 2, 50%. Okay. So now you come to the second condition. So B got head, three head together. Then he got the tail. Then what is the probability of the three head? It will be half, like 50% multiplied by 50%, half, and multiplied by half, which is 50%. If you multiply this, then also you will get the value 0.125. So just you see, getting three head together, the probability is 12% only. Okay. So okay, that can also be acceptable. That can happen due to the chance. Okay. C got head, and tail. So less probability it will get eliminated. Now, what about what happened with the D? D got head, then tail. So four head together. Okay. So what would you believe the D or reject him? So many of you might think he was doing some trick, but some may accept it as it's just a good luck. Maybe that is also possibility. Four head can come together consistently. So maybe the good luck is favoring that person. So may get four head together. But what about E? E is he got head, and tail. So what you will think? The majority, if not all, will reject him thinking that he may have cheated, etc. Isn't it? So you may feel like that. But the fact is that according to the law of probability, there is definite, though a small probability that it has all happened by the chance. Okay. So there will be some probability always. So let's see. What is the probability of the 5 head persistently coming? This probability is half multiplied by half multiplied by half multiplied by half multiplied by half. So 5 head together, it is 0.03. So what is the probability? Very less probability, okay, for getting this 5 head together. So only 3% probability that it will get by chance. Okay, so what we can say, the probability is very low for getting the 5 head together. So 3%. So thus, if you see, when the use of the probability of event happening by chance is as low, if the probability is very low, happening by chance is very low, like in this case 3% only, majority of the people would reject it. So early statisticians have decided, based on the similar logic, early statistician decided that if the probability of something happening under the null hypothesis is less than 5%, then they recommended to reject the null hypothesis and accept the alternative hypothesis. Okay. If the probability for getting two groups similar is very low, then we will reject the null hypothesis. We will say there is true difference or the things are happening beyond the chance. Okay. So that's why early statisticians have decided this 5% cutoff. Then so we will say that in the statistical term, result was statistically significant. Okay, this is the concept of the p-value. Anyone will so ask you, then this is the concept for the probability value. Okay, so there is another thing for the p-value. Whenever you do the data analysis, often you will see somewhere the statistical output will give you one-tailed p-value, sometime it give you two-tailed p-value. Any participant know what are the difference between the one-tailed p-value and the two-tailed p-value?
Sir, one-tailed
Any
is
participant
when
have the idea about this? You can write in the chat. Yes? One-tailed? Anyone want to speak?
yes, sir. One-tailed when we reject the null hypothesis.
Okay.
That that means accept the alternate hypothesis that there is a difference. And two-tailed will give you one particular direction, whether it is more or less compared to the uh, whichever standard we are comparing with.
Okay. Any other participant want to give some?
One
Yes.
one tailed, we can say that either the data is more positively skewed or
Okay.
negatively, or two tailed means it is in the half of value it can be.
Half of value it can be. Yeah. So any other participant want to speak some other thing?
Sir,
Yes.
I think in one-tailed, the probability of rejecting null hypothesis is in one direction, while in two-tailed, it can be on the either side of uh, the mean value. So means
Yeah. So your name is Vijayasri, no?
yes, sir.
So Vijayasri got this point. The difference between what is the one-tailed and the two-tailed. So the difference is only one. It will depend on the direction of your hypothesis. Okay. Now comes with what is the direction? What is the meaning of the direction? How we will know the direction before applying the statistical test? But the answer is yes. There are some hypotheses where priorly you know the direction which group is better. Okay, I will give you the example where you will know the direction. But let's see. So what has Vijayasri have told you? One tail when you know the direction of the hypothesis, which group is better, right from the beginning of doing the statistical analysis. Okay. And two tail, you don't know the direction, which group is better. Group 1 is better or group B is better, or drug A is better or drug B is better. You don't know anything. Then so you will apply two-tailed p-value. Okay. So before going to this, I want to ask from you. So one tail, if you know the direction, two tail, you don't know the direction of the hypothesis testing. So now you have to tell me, in this case, all participant, I want participation from maximum number of the participant. What do you think? I want to compare the IQ between normal children and the children with the Down syndrome. One-tailed or two-tailed p-value? What do you think in this case?
One
Translate.
tailed.
One-tailed, sir.
All participants, please try to participate.
The one-tailed, sir.
Yes, sir.
All of you agree with the one-tailed? Anyone want to tell me if two-tailed HSO can be applied? So most of you are writing one-tailed. Yes, correct, because you know the which group will do better. So Down syndrome children who are suffering with the Down syndrome will have the less IQ than the normal school-going children. So similarly, in many times like the drug company you see, there is non-inferiority type of the study design where the pharmaceutical company want to test the drug which is new drug is non-inferior to the already existed drug which is being used in the practice. So now question is why the drug company want to do the non-inferiority study? Because the reason behind this, suppose there is condition we used to see in our so neurological so disease which is called Guillain-Barré syndrome. The standard treatment is the IVIG immunoglobulin. So this costing is very high for this drug. So everyone cannot afford this drug. Okay. So there should be some alternative. So if this is the patient cannot afford it, then also what we say we get that so the steroid. Steroid is the cheaper drug, and cheaper drug means what we can say drug is cheap and this drug is non-inferior to the I already existed drug which is called IVIG. Okay. So means what? Suppose IVIG is improving the patient 60% improvement we are seeing with the standard drug. So even if it is not available, we can give the steroid that can also improve at the 50%. And 50% improvement is acceptable to the clinical community. Okay, this drug is not as equal as to the IVIG, but also it can also helpful for the patient. So in this type of the trial is called non-inferiority trial drug trial. So most of the pharmaceutical used to do this type of the trial, which is called non-inferiority trial, where the one-tailed p-value is being okay, one-tailed p-value. No need to do the two-tailed p-value in this case because we already know steroid will not be better than the IVIG. It will be non-inferiority we want to test. Okay. So now in this case, what do you think? One-tailed or two-tailed p-value? You can write in the chat box. So two-tailed p-value, very good because we don't know the direction. The IQ of the male will be higher or female will be higher. Okay. So we cannot have so know right from the beginning. So in this case, we will apply two-tailed p-value. Okay. So very correctly, you all have written in the chat box. I'm happy with this. Which p-value is significant? Quickly, so you write in the chat box. C and E.
C, sir.
C and E. Many of you are writing C and E. And some are writing only C. There are confusion among the participants for the p-value. Okay. Those who have written the E and E, what is the E? What is the p-value in this case of E? Is it less than 0.05? No, someone are writing ABC. Even B is also significant. No. P-value cutoff, what I told you, less than 0.05, 0.05, 5%, less than 5%. Okay. So in decimal term, it should be less than 0.05. So which value is less than 0.05 in this case? Each E is less than 0.05? Those who have written C and E.
Only C.
Only C, yes, only C is correct. Only C. So those who are writing E also, E is not statistically significant because for any time you will see it should be less than 0.05. So E is not less than 0.05. Okay. So we will not say E is significant. Only C is significant. Okay, in this case. And rest A, B, D is also not significant. So I hope it is clear to all participants. Okay, only C. Yes, correct. Now another question, then I will come to my topic. Can p-value be 0? Many time has so you will see in the statistical analysis software, like someone is telling me SPSS. So SPSS will give you the value p-value 0.000. Can it be 0? Ideally it should not be. No, no. Most of you are writing no. Then why statistical software gives the output 0.00? In non-inferiority trial, one-tailed p-value we will use because we know the direction, the drag which is non-inferior to the existing drag. Yes. No, meaningless. Meaningless, no. Yes, probability never be 0. Probability never be 0. No. So there will always be some probability. Okay. In only one condition, we will say the p-value 0 is possible. Anyone can let me know at which condition we will say p-value is 0? There is one situation in our life, we will 100% sure that event will occur. 100%. Which event will 100% occur? Yes, death. Someone has written death. Everyone will have to die one day. Okay. So if anyone will ask you what is the probability for dying any person, then you will say p-value is 0. That is possible. Okay. Apart from the death, apart from that, there is nothing which is 100%. Okay. Nothing is 100%. So we will say the p-value, if it is any paper, you are doing the hypothesis testing, it is written 0, you should not accept it, you should not write in a paper or report in the paper, p-value 0.000, you should have so write it less than 0.001. This is the way correctly, that is correct way to write the p-value less than 0.001. Okay, so very less probability, very less rare, has so probability to become the similar, it is very less that you can write, but ideally you should write with less than 0.001. Okay, so now we come to the parametric test, statistical test. Why we apply this? Today we are covering the parametric test. So when we use the parametric test, so now again there is question. Suppose a boy is 5 feet and 7 inch tall. Okay, so this is the height of the boy. What height of the girl is most likely to marry him? Participant, what do you think? Question is clear or not? Boy height is 5'7". So what
It
height
may
of
be
the
5
girl? Less than 5.7, is it okay? So less than 5.7, then 4 feet also is acceptable. So same height or less. So what do you think? Need to test the hypothesis both higher or lower. No, we will test the hypothesis later. I am covering the parametric test. Why we use the parametric test? Then I will come with the hypothesis test. Just a simple question. You have to guess and tell me. Suppose a boy height is 5 feet and 7 inches tall. What height of the girl is most likely to marry? Most likely, I am telling. Some are telling less than 5 feet 7. So less than can the 4 feet also. So do you think 4 feet also girl will be okay? Near 5.7.
Sir, we have followed the assumption.
Yes. What assumption?
Assumption is that the height of the girl should be at least 5 feet 7 inches. So you have to follow the assumption here.
Yeah, assumption I will come later. Just I have simply I want to know a question. What do you think if the boy height is 5 feet and 7 inches? Which will be the most suitable height girl to marry with this boy?
Less
Height
than,
is less than
less than 5 feet 7 inches.
So less than 5.7, 4 feet is also less than. So 4 feet is acceptable. My next question to you. 4 feet is also acceptable to you?
General cases, it's not acceptable.
Not acceptable. Yes. So you are saying it is more or less. So it go around 10% of within the 10% of the boy's height. Okay. So that has so you will have so okay. So you will have so go with. Suppose there is another question. Will he most likely marry a girl who is 6 feet and 4 inches? What do you think? Yes or no? That is your answer. I want to know. What do you think? Never. Rare instances. Very rare instances. Yes. But I want the average thing. Averagely, you want, there is no chance that it will have so very never or very rare, you can say. Okay, very good. Very good. And so you have. So will he most likely to marry a girl who is 4 feet tall?
Unlikely, sir.
This is also unlikely, very rare, isn't it? This is also unlikely. No or very rare. So 6.4 you are telling very rare, and 4 feet tall also you are telling very rare or unlikely. Very good. This is the answer I am expecting. Yes.
I think.
Yeah, pardon.
Yes, sir. Yeah, you are discussing about the class interval. Usually that you are discussing the 6.7 and you are discussing less than or more than that. That is the class interval.
No. I am discussing only the parametric test. Why we do the parametric test? You will know after 3-4 slides when I will cover it. Okay, so please wait for 2-3 minutes more. Okay. So let us cover me. Let me complete. Then I will also take your question. So interesting. Most people also marry someone around the average height. That is, everyone is acceptable. This thing, yes. Okay, so interesting. Most people also marry someone around the average height also person. So let's see. Our next question is: are most Indians are extremely short? Suppose Indian height. Someone is asking you about the Indian height. So no, many of you will tell most Indian are not extremely short. So most Indian are extremely tall also. Tall means more than 6 feet. No. So you are also saying no. So what we are saying, suppose for the height example, for any type of the population, we want to cover, then what we are seeing in the population, we are seeing the average people number is more. So very short people and very tall people are very less frequency in your population that we used to. So what is the average height in the Indian population? Anyone will write? What do you think? What is the average height? 5 to 6 feet. That is the range you are giving. No. 5 to 6 is the average among the Indians. So 5.5 is the average, or 5. Someone are writing 5.3 is the 5.5. So, okay, this is the thing you are coming to your mind. I completely agree with your observation that that could be the average height in the Indian population. Very good. So let us see. Why does this happen? Okay. Why the average thing is more in your population? So whenever you go to any market, any mall, anywhere, you will see whatever the average person, their frequency will be more in the population, isn't it? So If this type of the thing is happening, why? Height depends on what? Many genes, environmental factor, hormone, and when many small factor combine. So when these things will be there, then nature produces a bell shape. Okay. So bell shape is coming from this way only. Whenever you collect the data or any data in your biological setting or any community study or whatever it is, you are getting the bell shape curve. Means what is the meaning of bell shape curve? So if every person are getting equal opportunity to get participated in your study, so your data is representative to the population, then you will get the bell shape curve. Meaning is that the person who are average in that population, their number will be more. Okay. And who are very rare, like in the very shorter people or very taller people, their number will be very low. So whenever you go from the right hand side and the left hand side from the mean, their number will get decreased, okay, in the population. So what type of the thing you will get? You will get bell shape curve. This is the bell shape curve. Whenever you want to do the parametric test, you should have this type of the distribution for your data, not for the group data, not for the other data, only for the outcome data. What outcome data you want to compare between the groups? Okay, like suppose we want to test the height between male and female. Then so height data should be normally distributed. Okay, so let us see in this example. So the average people number at the middle, their frequency will be more when we draw in a histogram. So their frequency will be more. So they will be at the top. So it is taking in the bell shape curve. And that whenever we are going to the left hand side, the height is getting the shorter people distribution number will be very less. So as you are going, very less heighted person will be very less in the population. Similarly, it is happening with the right hand side also. The taller people number will be less in the right hand side also. Very tall people number will be also less. So what does this give us? The bell shape. Bell shape give us the idea about that, the distribution of the data. So what data you have collected, that is representative to the population. In this example, because every individual got the equal opportunity to get selected in your data. So representative data. Okay, so bell shape curve should be there whenever you apply the parametric test, which is very powerful test whenever you test your hypothesis. So now suppose if every y in the India was exactly 165 centimeter, could we get a bell shape curve? What do you think? Suppose this is a hypothetical scenario. Every boy's height is 165 centimeter. Will we get the bell shape curve?
So
If the same value for the height for every person, no, yes, we will never get it. Then we will get the straight line. Okay, so there will be no any variation. So we will get the straight line only. So this is not possible. Normal distribution exists because there is variation. Every individual will not have the same height. There will be the variation, but at the limited range. Okay, so frequency for the average person will be more in your population, and the rare so person will be very less. So that is the thing, and the variation is balanced. Balance means the very tall people and very short people also will be very less in the population. Okay, so no any extreme bias. This type of the data is there with you. You will say the data is normally distributed, and you are very easily you can apply the parametric test whenever you get this bell shape curve for your data, what you are seeing. Is hormone value is normally distributed depending on the number of the subject, because hormone value, if you have the adequate number of the test, number of the people, suppose any hormone you will say TSH, what do you think? Very high value will be very high or very less value? So it will be balanced. So within the normal range, what the laboratory have set up, so most of the people you will get within that range, and very less TSH value or very high TSH value will be less in your data set. You can examine it, but for the testing hormone data, you should have the what? You should have the adequate number of the subject. Representation is very important because because so adequate number for testing the small difference is high number will be required. Okay, will it be skewed? So depending on the distribution, many times we in some cases we are not expecting that normal distribution will come, isn't it? Like suppose duration of the hospital stay, it will never come that it will follow the normal distribution in this case. So in that case, we apply the non-parametric test if we don't have the adequate number of the sample size and seeing the all these things. So, but what message I want to give you, whenever you test the distribution of your data and you are getting this bell-shaped curve, means it is representative to the population, you will freely apply parametric. So what is this bell-shaped curve represent? Suppose this is 100%, okay. This bell is covering the 100% frequency of your this data. Then the middle value is the mean, median, or mode, we can say. So within one standard deviation, it is approximately 8% of the data will cover, and within the two standard deviation, it will cover the 95% of the data. Okay, and this is the cutoff value for the p-value, the testing the null hypothesis. If that beyond this 5%, the rare region it will come for the probability value. It will say statistically significant difference. The groups are not similar. Okay. So now we will go to the our statistical testing. I hope some of you have downloaded the software Jamovi, which is very user-friendly software that you will come to know after some time. So key properties of the normal distribution is what? Key property of the normal distribution is what? Should be symmetrical around the mean. So is it symmetrical or not? What do you think? Yes. ये देखिए ये सिमेट्रिकल है, दोनों तरफ है सो इक्वल है, सो डिस्ट्रीब्यूशन है, सो इट इज सिमेट्रिकल. तो मोस्ट ऑफ द वैल्यू नियर द सेंटर है या नहीं है? यस. देखिए बीच में है सो सबसे ज्यादा वैल्यूज है ना. And why within one standard deviation 68%? So it is once you do the experiment, you will know 100% data. Then within one standard deviation, after doing the many statistical testing, it will come to know once we standardize the values, it is falling within 68% of the data within one standard deviation. Yes. So now has so equal tail for both the side hai ya nahi hai? What do you think? Equal tail, is it there or not? Yes, it is there. So mean, median, and mode. Whenever you see this thing, mean which is the average value, which will be at the middle, the median will also be at the middle, and the mode will also be at the middle. Okay. So this is the so distribution, normal distribution. In simple term, in one line, what I will say, if your data is representative, means your data you have collected uniformly, every individual you have given the equal opportunity to get included in your study, then so you will get this type of the shape. Okay, average people is more. So now you see key properties that we have discussed. 99% CI I will cover when the time will come. So now so we have to come to our hands-on exercise. It is the applying the statistical test depend on what? It is variable, types of variable. Okay. What is types of variable? Whenever you read the statistical book, you will see there are categorical variable and continuous variable. And many book will write so what we can say interval variable, ratio variable, ordinal variable, nominal variable. There are many names, but you need not to get confused. Okay, you need not to get confused. You have to remember only two things: categorical data and continuous data. Okay, categorical data means what? When you are collecting the information in limited categories like yes no format or binary format, death alive, male female, all these things, then you will say our data is categorical. I'm not covering the metric, non-metric. There are different names, but for applying the statistical test, you need to know only the two types of the data. Just make it simple. Because as so, you will get confused if you read the book. You know, there are various names. If you remember these two types, you can apply all the tests. Okay. So just for this class, you remember only this categorical yes/no format of the data, and continuous variable means exact numerical value what you are collecting for the information. Like suppose we want to collect the age. We will not say age yes or no. We will get the exact age. Okay, whatever the age of that person. Or it often has the unit also. Like for age, there year is the unit. Similarly, okay, whenever you collect the information in the numerical format, that is called continuous variable. And categorical variable means you are categorizing the information in the category like yes, no format, okay, or mild, moderate, severe, something like that. So these are the two types of the data everyone should know, because this information is very important for knowing what test we will apply at what time. Okay. So now it depends on the types of the data to be collected. So let us see what are the continuous data. Any real number can take infinite number of the values. Okay. Like age, BMI, total cholesterol, HbA1c level, and categorical variable data is collected in the categories, two categories, like in case of binary, male, female, dead, alive, young, old. So now I have question from the participants. Just let me answer very quickly. Age less than 50 and more than 50, it is categorical data or continuous data?
Categorical.
Categorical.
Anyone will say continuous. Some Vedika has written it is continuous. Vedika Maheswari. So, no sir, for age. No, just see in first has a question. Age less than 50 and more than 50. It is categorical or continuous?
Categorical.
Categorical.
Categorical. No, only two category we have. Although we might have collected this information in continuous, but Dr. Madhu has written it is continuous. So, Dr. Madhu, what I told you, just you see my previous slide, continuous data only when we collect the information in real number. So, if age we will collect in the real age. Suppose we will ask what is your age. So, someone will tell 50, 59, something like that, whatever their age. Okay. Then it is the numerical format. Then we will say it is continuous data. Okay. But if we are collecting the information in yes or no format, then it is categorical data. So age less than 50 and more than 50. We have only two information. If the participant who are visiting to you, you are asking whether your age is less than 50 or more than or equal to 50. You are asking only two things. So you are collecting your information in categorical nature. So in this case, this type of the data is categorical data. Is it clear or not?
Yes,
Dr.
sir.
Madhu? So it is clear. So it is,
Can be changed into
yeah, it is categorical data. So now age in years. Age
continuous
in years.
data
Continuous.
can be changed into
Continuous, sir. Age in years, continuous.
Continuous. Total glucose level in blood is what? Continuous categorical.
Continuous.
Continuous.
Glucose
Total
also continuous.
Total TLC count.
Continuous.
And what about recovered and not recovered?
Categorical.
Categorical.
And total cholesterol level in blood?
Continuous.
Total
Continuous.
categorical.
Categorical. Total cholesterol level is categorical.
Yes. Yes, sir.
Continuous.
No,
Continuous.
no.
Continuous data.
Once you are going for blood testing, what value you see in the report for total cholesterol level? You are seeing cholesterol yes, no, or you are seeing some value?
Value.
So anywhere there is value, then it is continuous data.
Okay. Sorry, sir.
Isn't it? Categorical mean yes, no. Okay, present absent. What about the HbA1c level? It is continuous or categorical?
It is also continuous, sir.
It is also continuous. What about vegetarian, non-vegetarian?
Categorical, sir.
categorical.
Categorical. Very good. If you know this thing, know this variable classification, then applying all these tests is very simple for everyone, because this is the basic thing. Once a student don't know, then so application is very difficult. But if you know this thing, the nature of this classification, you can apply any test. Okay, so you will see after some time. So what are the example data set with me? So what for the hands-on, what we are going to do it now. I have collected this information from my one of the statistical analysis workshop. Okay, and what we collected the age data. What is the age? We collected the gender, we collected the height, we collected the weight, blood glucose level, whether they use the iPhone or no use of iPhone, their designation, and we collected the food choice, whether they are vegetarian or non-vegetarian choice, and systolic and diastolic blood pressure. That information we collected from the participant. Along with this, we have given the statistical question. Okay. So this was the 3 days workshop. So baseline has, so we have given the question, 20 question, to score them, to test them, whatever the level of the knowledge for the statistics among them. Okay. So before the start of the workshop, we collected the information. Next day also we have distributed the same questionnaire, and at the end of the workshop, the same questionnaire were distributed among the participants, and just we saw the change in their knowledge, whether HSO doing workshop improve the information or not. Okay. So let's see. Analysis, once we come, it is also descriptive analysis and inferential analysis. This is the two part we have divided the analysis. Descriptive analysis, whenever you want to describe your population, then we use the descriptive analysis. So where we are not using the p-value in this case, okay, because we only want to describe the population, like how many male or female were there, how many were hypertensive, non-hypertensive, what are the mean age among the participants. So these things we show in the descriptive statistics. In the inferential statistics, what we do, we test the hypothesis. So in the inferential statistics, the p-value will come. Okay. So no, the group were different or not. So these are the two ways. For the descriptive statistics, whenever your data is continuous, what has so you use? You use mean and standard deviation. Okay. For the normally distributed data, and median and IQR for the not normally distributed data. If your data is skewed, not representative, then you will use median and IQR for the descriptive statistics.
And what is IQR, sir?
IQR is the interquartile range.
Okay.
Okay, you will see in the descriptive statistics, because it is if your data is normally distributed, standard deviation can give you the better estimate for the variance among the population. Okay, but if it is not there, data is skewed, then IQR will be the better estimate. Okay, it is called interquartile range, and along with the median, we use interquartile range. Is it okay? Is it okay?
Okay, sir. Okay.
Okay, we will see how to do this thing. We will how to derive this thing. We will see. And whenever the nature of the data is categorical, like hypertension, yes, no, male, female, you collected, recovered, not recovered, iPhone use, no iPhone use. Okay, so in this case, you will use number and percentage. Okay, to for the descriptive statistics. So this is the common. So this is the very small SO thing I want to ask. This is the data I have collected. I want to know what descriptive statistics you will report for the age. Just you see the age data in this case, in this table. What
Mean
descriptive? Yeah,
Mean standard deviation.
mean and standard deviation. If data is normally distributed, if it is not normally distributed, then you will use median and interquartile. Very good. What descriptive statistics you will report for the gender in this case?
frequencies,
Percentage.
Number and
percentage.
percentage. Number and percentage.
Number and percentage.
Very good. So descriptive statistics is completed. Okay. So I will cover the descriptive statistics after some time in Jamovi, how to calculate this thing.
Sir, what is
Uh,
Jamovi? I have no.
Jamovi, no, just I'm writing. You just download this thing. No, download this one. This is the software. Okay, this is freely available software. Anyone can use it free of cost. Just it will take 5 minutes to download. This is the software I'm using for the hands-on. Okay, it is very user-friendly software. You just
सर
write.
डाउनलोड कर सकते हैं इसको?
हाँ, आप डाउनलोड कर सकते हैं, फ्री है, ये फ्रीली डाउनलोडेबल है,
ठीक
कोई
है सर।
पैसा नहीं लगेगा इसमें, और आपके लिए हमेशा ये काम करेगा, तो आप
तो
इसको
फिर
ऐसो डाउनलोड
SPSS की
करिए।
जरूरत नहीं पड़ेगी सर इससे?
SPSS जैसा है?
एसपीएसएस जो है ना, उसमें बहुत पैसा लगता है, उसमें उतना पैसा सबके पास नहीं होता है ना, तो आप ये वाला यूज
तो
करिए, ये
सर
फ्री है।
अगर सपोज हायर स्टैटिस्टिक्स करनी है किसी रिसर्च में, तब फिर
हाँ,
जमोवी काम करेगा?
हायर एकदम उससे ज्यादा एडवांस है ये जमोगी, एसपीएसएस
ओके
से भी ज्यादा एडवांस है ये, इसमें उससे ज्यादा फैसिलिटी है करने का।
ओके सर।
वो अभी आप देखिएगा ना, जब मैं अभी दिखाऊंगा आपको कैसे होता है, और उसमें आप मेटा एनालिसिस भी कर सकते हैं, उसमें आप सब है, वो सारे जितना भी जनरल टेस्ट हम लोग यूज करते
मुझे
हैं।
ऑक्सा बिंडर निकालना है सर, वो निकल
क्या
जाएगा?
क्या करना है?
ऑक्सा बिंडर।
बिल्कुल हो सकता है, उसमें उसमें लाइब्रेरी है, लाइब्रेरी में जाके आप उसको वो पैकेज इंस्टॉल करके कर सकते हैं। मीन्स है, सो आई विल शो यू अभी कैसे करते हैं, बट लेट अस कवर द पैरामेट्रिक टेस्ट फर्स्ट।
ओके
Okay. So why I have not used the SPSS, because it is a paid software. So Jamovi is freely available, and most of the statistical analysis we can able to use it very है so comfortably, और उससे ज्यादा आसान है, SPSS से भी ज्यादा आसान है, ठीक है। और क्विक एनालिसिस करता है SPSS से, SPSS में अननेसेसरी आउटपुट बहुत ज्यादा आता है, इसमें उतना ज्यादा काम की चीजें आती हैं बस जो हमें चाहिए। सो लेट अस सी। नहीं नहीं, रेफरेंस में कोई प्रॉब्लम नहीं होगा, आप देख सकते हो पब्लिश पेपर में ये वाला है, सो जमोवी को लोग साइट करते हैं, और ये जो सॉफ्टवेयर है आर आर का नाम आप लोगों ने सब लोगों ने सुना होगा, उसी का ये यूजर फ्रेंडली वर्जन है, सारा प्रिंसिपल आर का ही काम करता है इसके पीछे। बस आर ग्रुप वालों ने एक है सो सिंपल सॉफ्टवेयर डेवलप कर दिया है कि आप ऐसो उसको, जिन लोगों को प्रोग्राम लिखने में दिक्कत होता है, क्योंकि आर इज प्रोग्राम बेस्ड सॉफ्टवेयर जिसमें हाथ से लिखना पड़ता है प्रोग्रामिंग,
सर, कोई लिंक मिल सकता है इसका?
लिंक है सो अभी मैं शेयर कर देता हूँ, है ना। आप
हाँ,
गूगल
थैंक यू सर।
गूगल में लिखिए ना जमोवी, गूगल में,
सर
गूगल में
मीटिंग के
लिखने
बाद करेंगे हर वो तो।
गूगल में कर दीजिए अभी, आप 5 मिनट में हो जाएगा ये, इट विल नॉट टेक मच टाइम।
सर वो आपकी क्लास के बाद।
अच्छा अच्छा, ठीक है, मैं लिंक है सो शेयर कर दूंगा, है ना
ओ
अभी।
सो नाइस, थैंक यू सर।
हाँ,
सर
तो
ये एंड्रॉइड बेस है?
एंड्रॉयड नहीं है, विंडो पे काम करेगा ये, ठीक है,
ओके।
विंडो में काम करेगा, और उसमें भी करेगा आपका ये जो आईफोन, ये मैक मैक जो है सो उसमें, है ना। तो विंडो में अभी मैं दिखाऊंगा हैंड्स ऑन करके, ठीक है। तो एनीवे है ना, अभी देखेंगे इसको कैसे करते हैं, बट लेट अस गो टू द डेटा में अभी हम लोग जाते हैं। तो दिस इज द सॉफ्टवेयर, ओके। ये वाला जिन लोगों को देखना है कैसे डाउनलोड करना है, मैं दिखाता हूँ, अगर आपको फॉलो कर रहे हैं मेरे स्क्रीन को, तो आप लोगों को कुछ नहीं करना है, बस ऐसो यू हैव टू राइट यहाँ पे जमोवी, है ना, ये स्पेलिंग देख लीजिए, JAMOVI, है ना। ये करने के साथ ही ये आ जाता है इस तरीके का, जस्ट इसमें है सो इसको अगर आप ओपन करिएगा, तो एक क्लाउड है, एक डेस्कटॉप है, डेस्कटॉप वर्जन आप डाउनलोड करके रन कर दीजिए, है ना। 5 मिनट, 5 to 7 मिनट है सो लगेगा इसमें। ये जो सॉफ्टवेयर आप मेरे विंडो में ओपन देख रहे हैं वो आपको मिल जाएगा, ठीक है। और इसको, इसका मैं लिंक है सो अभी आप लोग को शेयर कर देता हूँ।
सो नाइस, थैंक यू सर।
SPSS से भी कर सकते हैं, बट आप ये वाला सॉफ्टवेयर यूज करिए, बहुत क्विक है सो काम करता है, और कोई भी आउटपुट में कोई चेंज नहीं आएगा, दोनों है सो सेम होता है। ये मोर एडवांस है SPSS से भी, जो आप रियलाइज करोगे अभी थोड़ी देर के बाद। तो लेट अस सी, हम लोगों ने एक डेटा कलेक्ट किया था स्टैटिस्टिक्स वर्कशॉप का, आप लोगों ने देखा, और हम लोगों ने क्या क्या इंफॉर्मेशन लिया था। वेरिएबल देखिए, ये सब वेरिएबल है जो कि हम लोगों ने लिया था। इंपोर्ट करना कैसे है, ओपन कर लीजिएगा फाइल, सीधा इसमें ओपन हो जाएगा। तो anyone want to do the hands on also? Should I share the data, Jamovi data?
Yes, sir.
Okay, so
Yes,
let
sir.
me share, let me share the data, so आप लोग खुद से भी कर सकते हो अपने से, follow with me. This one is the ये मैं जमोवी का फाइल डायरेक्टली आप लोगों को दे रहा हूँ। अगर किसी का एक्सेल है तो एक्सेल को भी आप अपलोड कर सकते हो। एक्सेल में जो माइक्रोसॉफ्ट का वर्जन है, अलग अलग फॉर्मेट होता है ना, तो 2003 और वो सिर्फ नोट पैड वाला वर्जन आप लीजिएगा, तब ये जमोवी में इंपोर्ट होगा वो एक्सेल में।
सर 365 में जमोवी काम करेगा?
इट विल वर्क, करेगा करेगा बिल्कुल करेगा। ये मैंने सो आपको शेयर कर दिया जमोवी का डेटा सेट। ये आप डायरेक्टली इसको ओपन करिएगा, ये खुल जाएगा आपका। जिन लोगों ने जमोवी डाउनलोड कर लिया है इसको मैं सेंड कर दिया हूँ। एक्सेल का भी फाइल में शेयर कर देता हूँ। जिन लोग अगर एक्सेल में डाटा कलेक्ट करते हैं तो वहां से भी, अगर आप सीएसवी में करते हैं, सीएसवी एक्सेल का एक फॉर्म है, सीएसवी अगर आप एक्सेल में जाके उसको सीएसवी फॉर्म में डाउनलोड करेंगे तब भी ऐसे जमोवी में खुलेगा। मैं सीएसवी फाइल भी आप लोग को शेयर कर दिया। और अगर किसी का एक्सेल डेटा है, okay, okay, someone is telling in Hindi, some are telling in English. Okay, so let us also go with the hands-on SO work. Okay, let us go with the hands-on work for the Jamovi. So this is the data. Please also, those who want to do the hands-on, please download, open this SO file in the Jamovi software. So what is the way to open? If the Jamovi file you have downloaded, just double click it, your file will get open. All of you who have downloaded this file can able to see this software.
नहीं सर, नहीं आ रहा है तो।
नहीं आ रहा है, so let me also go to this. Suppose this is the file, what you have to follow. मैं शुरू से कर रहा हूँ, just I am doing from the beginning. So this is the Jamovi file, just to double click it. Double click, then also it will open. Okay, so this one is the thing is happening, double click. So what you do, just follow
सही
follow me.
करंट में
No,
करंट या
follow
सॉलिड
it.
वाला कौन सा डाउनलोड करना था?
This one is solid.
ओके
Which one
सर,
SO
ठीक
you
है।
have downloaded? So those who have downloaded, just you follow with me,
Please
just you
share
go
the
to the
WhatsApp group, sir. Please share the WhatsApp group also.
WhatsApp group. Okay, I will share the data in WhatsApp group also. I shared the data to Dharmendra.
सर हम आपकी केवल स्क्रीन देख पा रहे हैं और कुछ नहीं हो समझ में आ रहा।
just a minute. मैं एक बार WhatsApp में भी I am sharing the data. So anyone, it will be circulated in the group. Okay. So just a minute. Jamovi file. So I have shared the data in the WhatsApp also. Those who have downloaded the data, just follow with me how to open this file. Okay. So this is the triple. Just see the left hand side, triple horizontal. Just you see. Okay. So just you click it here. Then also go to the open. Okay, open, because you have to open the file. So once you go to the open, and this window will appear. So it is the browse. So you click on the browse and you locate to the file where you have saved your Jamovi file. So this one is the Jamovi file where I have saved this data. So I will select this thing and I will click on open. So just I open the file in the our software. So it will appear like this. Is my screen is visible to everyone?
Yes.
स्क्रीन तो विजिबल है सर, लेकिन जब तक ये डाउनलोड नहीं होगा, हम लोग अप्लाई नहीं करेंगे, तब तक समझ में आएगा नहीं.
Okay, later on you will do by your own because time is not much. So
You can see
let's
the
see.
recording.
So
Sir,
this one,
later on I will do that.
yeah, please. What you want to tell? I hope this one is everyone can able to see this file in their screen who have downloaded this software. So let us go with the test, statistical test. So first I have told you, you have to use the descriptive statistics. Okay. So descriptive statistics, suppose for the age, what we want to know for the age for descriptive statistics, you have
Mean
told
and standard
mean and
deviation.
standard deviation. So where I will go to the exploration. Okay. The left hand side, it is exploration is visible to everyone.
Yes,
Left hand
sir.
side, just follow my cursor. I will click in the exploration, then descriptive. So once I clicked on descriptive, this window will appear. Okay. So it will ask you variable and sort by. So what variable we want to know for the age? Descriptive
Age.
statistics, we want to do the age. So I will select in the age. I will drag it to the variable view. Okay. So just I dragged it in the variable view. You can able to see the output. Can anyone will say what is the mean age in the study participants? What we have?
40.4.
What is the mean?
40.4.
40.4. What is the standard deviation?
7.39.
7. What is the minimum age
25.
25.
and maximum?
59.
Okay, so these are the descriptive statistics you can report it. Okay, and suppose you want to test the normality. Okay, I told you na the normality assumption also you need to check it whenever you apply the parametric test. So here in this option, the option is for the normality test also it is available. So what you have to only tick it. What the information you want, you have to tick it only in this. So there are many things. Suppose someone is want percentile, someone want interquartile range. Suppose if you clicking on interquartile range, the interquartile range is available. Okay, just you see. N is the interquartile for this data. So whatever the information you require, you have to tick it. You will get this information right hand side in this. So this is the Sapporo-Wilk test. Okay, this is the thing is the for the normality test. Okay, so what is the assumption for this? The p-value should be more than 0.05. Okay, more than 0.05, then the data is normally distributed. What is the p-value? Anyone can able to see? Sapporo-Wilk p-value?
0.40.
More than 0.05.
Is it normal or not? Sir, class level.
More than 0.05, sir. So
कुछ समझ में नहीं आ रहा सर.
So what I told you, normality testing, you remember, no? Bell-shaped curve we have to see. Is it, do you remember? If the data is representative, we will get the bell-shaped curve. Do you remember?
Yes, sir.
So now we are testing the normality. So there is p value we have seen. Okay, so before seeing the p value, let us see the plot. If you want to see the plot, the bell-shaped curve is there or not, you will click on histogram. Okay. So after seeing the histogram, what do you think? The distribution is normal or not? Bell-shaped or not? What do you think?
It is not normal, sir. It is not normal.
It is not normal. How many of you are telling it is not normal?
Not normal, sir.
सर नॉर्मल नॉर्मल तो है सर, लेकिन जो आप कर रहे हैं वो समझ में
It's normal.
सर
It is normal, sir.
Many one of you are telling it is normally distributed, representative. And many one are telling there is not normal, isn't it?
not
Slightly,
normal
slightly.
because
So
नहीं,
how
नहीं,
many of
हाँ,
you are
slightly.
telling not understanding anything? Or anyone who are telling you are
चार
not
डेटा जो है वो skewed है, इसलिए ये नॉर्मल तो नहीं है.
But that Shapiro's test says it's normal. So
Look like normal but not normal.
so
The mean and median is somewhat equal. That's why it's a normal distribution.
whenever you deal with the real data, okay, this is the real data, you will not get a completely perfect normal shape curve, isn't it? Like in
Okay.
SO, our hypothesis testing, you remember, no? So 2 head can be due to the chance, 3 head can be due to the chance. So 5 consecutive head, that is not happening by chance, that is beyond the chance, isn't it? So perfect normal distribution you will not get, isn't it? So whether it is significantly away from the null hypothesis or not, that is important, isn't it? So after seeing this plot, more or less you are seeing it seems like normal or not. What do you think? Normal means average value should be more.
Seems like.
It is in the middle.
Normal.
What do you think? Normal average value is more in number in this data or not? In the middle or not?
Yes,
Yes,
sir.
sir.
Seems like normal.
It seems like normal.
Seems like, yes.
Seems like. So now when we will know, we will have to do the statistical testing, whether it is normal or not. Okay. So what are the name of the test? I told you Saparo-Wilk test. Okay. Saparo-Wilk test. And null hypothesis is that it should be normal only when the p-value is more than 0.05. अगर p-value 0.05 से ज़्यादा है, if the p-value is more than 0.05, then we will say distribution is normal. Okay. What is the p-value in this case? Saparo value will p-value. Is it more than 0.05 or less than 0?
Yes.
More than.
So
More.
if it is
तो ये सपारो वैल्यू पहली बार सुन रहे हैं, क्या है?
Yeah, this is for the normality testing. जैसे t test we are doing now for doing the testing the mean difference between the two group. Okay. So Saparo-Wilk is also name of the test where we will test whether the data is normally distributed or not. Okay. So this is the statistical test for the normality testing.
स्टैटिस्टिक्स की बुक में नहीं है सर, कोठारी की बुक में भी नहीं है और कैलाश नागर की बुक में भी नहीं है.
No, it should be there. You will read in the Google or so good statistics book. It should be there. Okay. There are two.
नया concept होगा सर सपारो का.
Saparo-Wilk. No, so Saparo-Wilk test should be there. Kolmogno-Simirno test also is there. So in SPSS, both the test will come. Okay.
Sir, my humble request to you, please go ahead. ये Shapiro-Wilk कल descriptive statistics में बताया गया था. अगर हम ऐसे चलेंगे तो हम actually topic पे नहीं आ पाएंगे सर, please. This is my humble request, sir.
Yes, sir. Yes, sir. Shapiro-Wilk is covered yesterday only.
So it is already covered also. So let me proceed. Okay.
Yes, sir. Yes, sir.
So this is the thing what we have learned. This is the normally distributed data. So let us go with some our SO testing what we are covering. So what are the first test in the statistical test? This is the one sample t test. Okay. When we apply the one sample t test, okay, so there should be only one sample. And we want to know with some hypothetical value it is different or not. So in this case, suppose we want to use the one sample t-test for the age data. So suppose we want to know the participant who have attended this workshop, their mean age is more or less than a hypothetical value called 40 years. Suppose we want to know whether all the participants who have attended this workshop, it is away from the 40 year of the age or not. Okay. So only one sample, one hypothetical mean we have already derived. We want to test whether the age is different from the 40 year of the age or not. So in this case, we will apply the one sample t-test. So what are the process to do the one sample t-test? We have to go to the t-test. Okay, t-test. Then so any participant can able to see the one sample t-test here.
Yes, sir.
So
Yes, sir.
one sample t-test I will select. Okay. So in the one sample t-test, what we will select? We will select age. That is our hypothesis. I want to know whether age is different from the 40 year of the age or not. Suppose someone are telling, the person who are attending the statistical workshop, their mean age should be around 40 years. Okay. So what data you have collected, it is different from 40 year or not. Okay. So one sample we have selected it here. Then in the hypothesis, it will ask you what is the test value. Okay. So test value, I will write 40. Okay. So now I am testing it whether our data is away from the 40 or not. So once you have put this data 40 here, then so you will see the output. So the output will tell you the p-value it is giving you, statistics value it is also giving you, and the whatever the other descriptive value you want to take, just you click it. So descriptive statistics, suppose you want, you click descriptive mean difference, whatever the value you want, just you have to tick it and you will get it. Okay. So now anyone can able to find out whether the mean age of the participant who have attended my workshop is away from the different from the 40 year of the age or not. Anyone can able to figure it out the p-value with this output. Anywhere you are seeing the p-value?
Yes, sir.
Yes, sir. It is greater than 0.05. So
It
What
is
is the p-value? What is the p-value?
0.584.
It is the 0.584. Okay. So means what? The group are, all the participants are similar to the 40-year age or not? So null hypothesis is what? The age is similar, more or less around the 40 years. Yes. So we are accepting the null hypothesis. The mean age of the participants are close to the 40 year of the age. Okay. So p value is 0.058, 0.584. So we are not rejecting the null hypothesis. We are accepting the null hypothesis. This is the one sample t-test. Okay. The p value is clear. We can see the mean difference. What is the mean difference? Or suppose you want some descriptive value, you can able to see the descriptive value. What is the mean age in our workshop participant who are attending the workshop? Can able to see the value? What is the mean age?
40.4.
40.4, yes. And the median is 40, and all these descriptive values also available with you. So you can say one sample t-test we have applied. Okay. So now I am coming
Here,
to yes.
So here that hypothesis, is it null hypothesis or alternative hypothesis we are putting?
Null hypothesis was the participant who have attended the workshop, their mean age is 40 years, close to the 40 years. Okay. And this is our data, and this is the similar to the 40-year age, it is not significantly different from the our priorly SO fixed SO age 40 year, that is not different. Okay, it is 40.4, similar. Okay. So now you come to this one. One sample t-test we have covered. Now you come to this is very briefly, anyone want to know what test we apply at what time? The continuous parametric test. You just keep this slide with you. It will be clear. Every time it will be clear to everyone what test we will apply at what time. Okay. So first the thing will come, non-parametric test I am not covering. This is just alternative to the parametric. When the data is not normally distributed, you will go with the non-parametric. I will not cover this thing. So parametric only I am covering. So whenever you want to compare the two groups, X equal to groups like drug A or drug B, male or female, we have only two groups, not more than two groups. Just to take this example, you have only two groups. And the test variable, like the test variable should be continuous in nature. Continuous means numerical data. Okay. So y is the normal distribution, means test variable. We want to see, we have checked the normality, it is normally distributed. Let us take an example. We want to compare male and female, whether any difference in BMI. So BMI is the numerical data, and this we want to test between two groups, male and female. So if this type of the scenario will come, then you have to see the groups are related or not related. So just I want to know from you, the participant, male and female, we want to test whether the BMI is different between male and female. Male and female are related data or unrelated data?
Unrelated.
Unrelated data, because male and female are not related with each other. When the group is independent, you have only two groups, you will apply student t-test or unrelated t-test or independent sample t-test. These all are the same. Okay. Two group continuous data you want to test. Now you come to the related. If the assumptions are coming and the groups are related. Suppose, take an example. Suppose we want to take the pain SO in the hospital patient who are admitted to the hospital, and same individual we are assessing their pain scale at 30 days. Same individual. Then this group are related or not related?
Yes, sir.
Related.
So,
Pre and post.
so pre and post data, if pre and post
Sir,
data, you will
रिलेटेड और
apply.
अनरिलेटेड का मतलब क्या है सर? यहाँ समझ नहीं आ रहा है.
Group, whenever you do the hypothesis testing, it will be in the group or not. So suppose drug A or drug B. Okay, so these are the groups. Groups are unrelated, means one group is not related with each other. Then we will apply student sample t-test. Okay, and when the same
Both group are different, it means both group are different.
both group are not related. Not related means independent. Groups are independent. Drug A is independent and drug B is independent. Okay. Like in male and female. Male is different and female is different. They are not same, isn't it? So if this type of the scenario, then independent sample t-test. Unrelated. Okay.
तो स्टूडेंट टेस्ट लगाएगा.
Student sample t-test. And then group are related, like suppose same individual reading you have taken for 2 times. Pain score we have measured at the baseline, and same individual, suppose 30 individual you have included in your study, same 30 individual pain score you are taking at 30 days after the discharge. Okay, then what is happening? These are the related, because same individual you are reading at 2 different time points. Okay.
Pre and post
data, pre and post. If this type of the scenario will come, you will use pair t-test. Is it clear or not?
Yes, sir.
Is it clear now?
Yes, sir. Yes, sir.
Yes, sir.
So say pre-post data, pair t-test. If group are unrelated, independent, you will use student t-test. Okay. So this is the one scenario when the groups are only 2 or time point is only 2. Okay. Now you come to the more than 2 groups. Okay. More than 2 groups means like many time it happened. We have drug A, drug B, drug C. Okay. We have 3 groups. Or there are A, B, C or more than 2 groups. Many time we see. Isn't it? So if group are unrelated and more than so 2 groups are there, you will apply one-way ANOVA. Okay, one-way ANOVA is the name of the test to test the mean.
Sir,
yes,
Amit sir.
Yes.
Yeah, your voice is echo. There is a echo problem. I think there are two devices you are using.
No, sir. There is no echo here. Maybe, sir, you are using 2 devices. Just check, sir, again, please.
Voice is clear, sir.
Voice is clear. Okay. So participants are telling voice are clear.
Okay then. I
Okay,
will check
okay.
my
Let me
device.
explain. Yeah. So if you have more than two groups and you want to test the difference in the continuous variable, then you will use if the groups are unrelated, like drug A, drug B, drug C, these are not related with each other. Then one way ANOVA you will use. And the another thing, the situation will come when the groups are related, like same individual reading you are taking more than two time points. Like suppose at the baseline when the patient are admitted to the hospital, same patient you are observed for the same scale at 1 month and same individual you are assessing that same scale with 6 months. So three time point or more than two time point. Time point can be many time point. It is not a problem, but it should be more than two time point. If this type of the related sample will come, when there is more than two time points reading you have taken, you will apply repeated measure of the ANOVA. Okay, the name of the test is called repeated measure of the ANOVA. So anyone, you take the picture of this slide. I will ask you question. Whenever what test you will apply at what time. Okay, if this slide is clear to you, you can freely apply the parametric test in this case. And non-parametric test, maybe it will be covered tomorrow or some, maybe it is already covered to you yesterday. So this is the example. I want to know from the participant, after seeing this slide, you might have taken the picture of this slide and you have to tell me what test I will apply. Is there is difference in the diastolic blood pressure between male and female? What test I will apply?
Student t-test or independent t-test?
Any other participant you want to tell?
Independent
Student
t-test.
t-test.
Independent sample t-test. Okay. So why independent sample t-test? Just to see. We have only two groups, x equal to 2. So male and female are independent. They are not related with each other. And the continuous variable we want to test, which is the diastolic blood pressure. So difference in the diastolic blood pressure between male and female. So what test we will apply? Independent sample t-test. Very correctly you have identified. So in this case, what test we will apply?
Independent t-test.
T-test.
Independent sample t-test because difference in age between male and female. So age is the continuous data. It will be independent sample t-test. Very correct. So there are some assumptions that you need to know whenever you apply the independent sample t-test. Independence of the observation. So observation should be independent. That should not be correlated with each other. So every individual observation should be independent. This normality that we have already discussed, the variables should be normally distributed and the homogeneity of the variances. So variances means standard deviation. Okay. So the suppose one group standard deviation is very high, another group standard deviation is low. That should not happen. The variance should be equal in both the group. We will see in our hands-on also. Okay. So variance of the two groups should be approximately equal. If it is equal, we will go with the student sample t-test. If it is unequal, then we will correct it with the leave-in test to check it. And if it is not there, then there is correction is required, which is called Welch correction. That we will see in our Jamovi exercise. How to do this, the correction, very simple it is. No need to struggle much. So this thing we have to check whenever we apply the student sample t-test. So let us go to the data set. And so this is the data with us. You have to tell me, you just frame any question where we will apply the student sample t-test. These are the name of the variable. So any participant just tell me what test you want to do where the independent sample t-test can be applied with this data set. Anyone just frame a question. Any question? We have the age data, we have gender data, we have height data, glucose data, systolic blood pressure.
So difference in glucose levels between gender.
Difference in glucose level. Very correct. The glucose level is the continuous data. and gender is, we have two groups, male and female. Male and female are independent with each other. So we will apply independent sample t-test in this case. Okay. So now let me go for applying the independent sample t-test. Okay. So I'm going to the analysis. And whatever the analysis you want to do, you have to go to the analysis. And so t-test definitely, because we are going to do the t-test. Anyone, anywhere you can able to see the independent sample t-test after
Yes, sir.
clicking. Yes. So you just click on independent sample t-test. Okay. So this window will appear. Okay. Whenever you want to do the test, independent sample t-test, this window will appear. Now you have to help me to know if you want to test glucose difference between male and female. So what variable I will drag in the dependent variable and what variable I will drag in the grouping variable? Anyone can guess?
Sir,
Gender.
glucose will be the
Depend
dependent variable
Glucose
and
will be the,
grouping
yes.
glucose
So
in the dependent variable and
gender in the
gender
grouping
into
variable.
the grouping variable.
glucose I have already dragged in the dependent variable and gender I have dragged in the grouping variable. Okay. So now we have also selected all these things, and what the descriptive statistics you want, just you have to tick it. So you will get the descriptive statistics also. So descriptive. So now you have to tell me once I have ticked it. So what do you think? Which gender have the more glucose level after seeing these descriptive statistics? Anyone can able to see the mean glucose level?
Mean glucose level is more in the males.
Male 45.
It's in female, it's 130.
Male.
It's in female.
Male, it's 107.
Female.
No,
110.
female. Mean is more in females.
Glucose level is more in the female. And what about male?
107.
107.
107. So there are higher glucose level in the female, but need to check whether it is statistically significantly different or not. So anyone can able to help me to know what is the p-value in this case?
P-value is
You can see the p-value.
0.602.
0.602. It's not statistically significant if we set the bar of threshold 0.5.
Yeah. So yes, it is always 0.05. Somewhere we reduce the p-value, but we do not increase.
Exactly.
So
Yes, sir.
it is more than 0.05. So we will say yes. There may be some that can be due to the we will have some little higher level of the glucose level, that is, but statistically it is not significant. That variation can be due to the chance. Okay. So it is not beyond the chance. We can also able to see with after seeing the p-value, which is 0.60. So we are accepting the null hypothesis. The glucose level is similar between male and female. Is it okay? Is it okay?
Yes, sir.
Anyone have
Yes,
Yes.
it's
questions?
okay.
No.
So can you explain
Sir,
if
you
we
were
change the
telling about
hypothesis?
the homogeneity test.
Now I am coming to the homogeneity. The second assumption, normality we have already discussed. Now we are coming to the homogeneity of the variance. Okay, it is very important. So how to check this? So assumption check you are seeing now, this is the homogeneity test. Just to click it here, homogeneity. So once you click it here, you will see these values. So what are the values? You can able to see assumption homogeneity test, leave-in test. What is the thing? What are the standard deviation in the glucose? What is the standard deviation of the blood glucose level in the female for the blood glucose?
31.6.
1.6.
And what about in the male?
16.3.
16.3.
Different. It's quite different for both the genders.
But as well, assumptions that the standard deviation should also be homogeneous between both the group. Okay. If it is not homogeneous, then what we will say, the homogeneity of the variance assumptions violated. Then we need to correct it. How we will correct it, I will just let you know. But this is the only observation you are seeing. we have to see the p-value, the test for homogeneity p-value, leaving test. And what this test will tell you, if this p-value is very low, less than 0.05, then also low p-value suggests a violation of the assumption for the equal variances. So what is the p-value in this case?
0.0, 0.212.
0.212. Whether it is less than 0.05?
More than 0.05.
So more than 0.05 is acceptable to us. There is no any issue with the variance difference between both the group. Okay. This is the statistical test. So whenever the p-value is more than 0.05, you need not to correct for the variance. Okay. But whenever you are doing the statistical testing and the p-value for this, you are getting less than 0.05 for the homogeneity of the variance test, then you have to correct for the homogeneity of the variance. Now question is how to correct it. You need not to do anything, just you click on the Welch. Welch option is visible. Just you see the cursor of my mouse. I will click on the Welch. So Welch p-value you will have to get it. Okay. Whenever the p-value for is very low, less than 0.05, for the homogeneity of the variance test, then the Welch p-value you will take. What is the Welch p-value in this case?
0.621.
0.621. So, but in this case, there is no need for the Welch test because p-value is more than 0.05. Okay, so variance is homogeneously distributed between both the group. Okay, so we will use this p-value only. Is it okay, or any participant have some query? Because lots of other tests also I have to cover. So I will go to the other test also, and at the last we will take some question. So
does the number of people have impact on our calculations? Like how many number of males we have compared with the how many number of females?
How many number of?
The number between males and females, like suppose 10 females and 100 males, does it affect the p-value and other things?
Okay, the p-value, that is the matter for the power. Okay, if the groups number are one group are very high number, another group have very less number, then what effect will come? It will affect the power. Power is for sample size calculation, you know na? Whenever we calculate the sample size, we say that every group will require this number of the sample, like 100 in one group, 100 in the another group. That is the matching is required. In the case control study, we increase the number of the control also, 1:2, 1:4. Why? To increase the power of the study. Why we want to increase the power? Because if there is difference is small also, or difference is clinically relevant, that we can able to see it with our sample size. If the number is very less, suppose in one group, then the power of the study will be less. Then it may be possible that in the real practice, maybe statistical significant difference is there, but you may not get the significant p-value. So maybe there are higher chances that the p-value will not become significant, even though it is significant. Once you increase the sample size, then maybe the p-value will become significant. Okay. So in this way, the less sample size in one group will affect the p-value. Okay. The only power will get affected. A p-value will be higher in this case. Okay. That is in that way it will affect. So now I will come to just see this data set, and you have to tell me where we will apply the pair t-test. Any question, just you frame where we apply the pair t-test. Pair t-test, just you remember, same individual reading I should take for 2 times. Any data you are observing in this data set, where the observation what I have take one time and different time for the same individual?
So there is a data pre-start knowledge and day 2 statistics knowledge.
Yeah, pre-start knowledge and day 2 knowledge. So we want to know when they have not attended the workshop, and after the attending the workshop for the same individual, where the statistics knowledge increased or not. So very good. You have also point out the very correct question. So let me go to the pair t-test. How to do this? I will click on the t-test, then pair sample t-test. The option is visible here. So whenever you click this window will appear. Okay. So in this, we don't have the group. So all the pair variable you have to select in this box. So we have just also drag the paired pre-stat knowledge. Oh, sorry, in this case, this one, pre-stat knowledge and day 2 knowledge. Okay, so just you have to drag these two variable here in this case, and you take the descriptive statistics plot also. And I want to know from the participant, what do you think? Whether the knowledge is improving or not. What is the pre-start workshop knowledge mean in the participant?
से नॉलेज इंप्रूव होगी कुछ आता तो है नहीं समझ ही नहीं आ रहा है
It has
Sir,
improved.
increase.
It has improved, sir, because the p-value is
P-value is significant.
significant, highly significant, less than 0.001.
वर्कशॉप से पहले कितना मीन नॉलेज था? मिनिमम स्कोर 0 एंड मैक्सिमम स्कोर इज 20. What is the mean statistics knowledge pre-workshop?
8.93. Mean.
8.93. है ना? Just remember what is the minimum score? Minimum was 0, no knowledge. 20 is the question answer correct. So before the workshop, when we take the baseline, it is 8.93. Okay, this is the mean, and standard deviation is 3.40. Okay, what is the mean statistic knowledge in day 2?
13.57.
13.57. So it is increasing or decreasing?
Increasing.
Increasing. So this increase is significant or not? What is the p-value?
Significant. 0.001.
It is less than 0.001. Okay. So very highly significant p-value. In this case, we will say, after doing the statistics analysis workshop, knowledge for statistics is increased significantly. Is it okay?
Sir, what is the role of effect size?
Effect size is the when we also divide the change with the standard deviation, the effect size. Effect size is the, suppose it is the very high effect size, then we will also just estimate with the if you click the effect size, it will give you. Okay, this is the effect size. So cohendy, so minus 1.33 means very high effect size. If it is more than 1, then we consider it the statistic effect size is very high. I mean difference is very high. Means matlab changes happening is very high. If it is less than 0.
Butterfly wants father must
less
room
than
to let her in. This is what it says. Please, dear father must room. Let me come.
ఇతర లేయి పవిత్ర చదువు చెప్పేటప్పుడు లేక కూర్చొని చదువు ప్రాపర్ గా
Can we mute the
Polite way of
participant?
क्या
asking.
तमाशा हो रहा है कुछ सुनाई तो दे नहीं रहा है
Can we mute the participant, please? Thank you very much. So this is effect size is nothing. In the difference you are dividing the standard deviation, you are getting it more than 1. Very high effect size we consider. So what we have covered? We have covered the paired sample t-test. Then same individual reading we are taking for 2 times. We will apply paired t-test. Why here we apply paired t-test? We have assessed the statistics knowledge before the start of the workshop. Same individual in day 2.
Sir, one question from my side. Sir, one question from my side.
Yes.
Sample size should be equal in the case of t-test or pair t-test. Sample size.
Sample size in the pair t-test. So if the sample
less
size
than 30
No, less than 30. Not I'm asking the less than. In the case of independent t-test, sample size should be equal. If the number of male is 30 and the number of female is 40, then we should? Is there a rule the sample size is equal or not?
Let me answer your question first. Okay, so as far as sample size is considered, okay, what I told you, sample size come from where? Sample size come from the sample size calculation. Is it there or not? We do the sample size calculation, no, then we get the number. These numbers are required for doing our statistical testing. Suppose you have not done your sample size calculation, and the number is not equal between both the groups. That is the question you want to answer, want the answer for this, no? So suppose in the scenario, one group has very high number of the sample size, another group has very less number of the sample size. But whether it is what t-test assumption is telling you, that is you want to know, na?
Yes, sir.
So what the assumption for the t-test will tell you, first of all, what you have to see? You have to see whether for the applying t-test, the normal distribution is there or not, isn't it? This is the assumption. So when the normal distribution you are expecting, the sample size should be more than 30. Okay. That is the so when we apply the t-test, isn't it? Is it there or not? So sample size should be adequate. Now suppose one group has very less sample size, another group has very high sample size, suppose 4 times sample size. It will depend only in the fact that whether your power is okay or not. Power means where what hypothesis testing you want to test. Suppose with this lesser number of the sample size, the group who have very less number of the sample size. Suppose you have in a one group only 20 subjects are there. Okay. So in this case, suppose you don't have the adequate power as per sample size calculation, you have to do the sample size calculation. If 20 sample size is adequate, suppose in this your case, okay, suppose effect size is very big, very large difference we are expecting from our intervention. 20 sample size is also sufficient. Okay, in that case, t-test output will not get affected at any way. Okay. In that case, if your power is adequate, whether the group is equal or not equal, that is another thing. We have to know whether power is adequate or not. Okay. If the power is adequate, we can comfortably test the statistical test. Inference will not get changed. But if the power is less, then you will not see the statistically significant difference. In that way, p-value will get effect. Okay. Whenever there is a sample size class, there you will know very clearly this thing. Okay. Assumption is that it should be groups should be so equal number should be there, or but equal will not always be possible because there is loss to follow up is also there. Suppose in the statistics workshop example also, maybe first day there are 30 participants who have given the this exam, and second day there are dropout. 10 participants are not attending this workshop. Then the pair t-test we will analyze only 20 subjects. Where the group formation is not possible, it is not going to analyze that data, isn't it? So in this way, 20 subject is adequate or not. If the sample size calculation is telling you, yes, 20 is adequate for this testing this hypothesis, p-value will not get affected. If 20 is not adequate as per the sample size calculation, yes, p-value will get affected. Is it okay or not?
Okay, sir. Okay.
Okay. So in this way, so because I have to cover more tests, so let me go to some other tests. Time is not much. So what we have covered? We have covered the independent sample t-test. We have covered the paired sample t-test. So now I will go with the ANOVA. So ANOVA example, just you have so see this slide. ANOVA, just you remember this slide. What is the assumption for the ANOVA? ANOVA assumption is number of the group should be more than 2. Okay. Group number should be more than 2 and it should be unrelated. Like drug A, drug B, drug C. The same observation should not be repeated. Then so we will apply one-way ANOVA. So can you say me what test we will apply in this case? Difference in the blood glucose level among treatment A, treatment B.
ANOVA.
One-way ANOVA. ANOVA has
One-way ANOVA.
ANOVA has different names. ANOVA, two-way ANOVA, many other names.
Okay.
In this case, you have to use only one-way ANOVA. Okay, one-way ANOVA is the correct name. In this case, what test we will apply?
One-way ANOVA.
One-way ANOVA, yes, correct. So now you have to tell me in this data set, the data variable is with you. Can you frame any question where we will apply the one-way ANOVA? in this case? Anywhere you are seeing the group number is more than 2? Any variable you are seeing where the number of the group is more than 2? And continuous variable, we want to know the difference.
Participants data hands-on workshop.
So groups will
Designation.
Designation more than one categories, and then we can have the any continuous variable paired with designation.
So any continuous variable, can you name any variable?
Can we see height of the
Height also we can see. Can we
weight, age?
Age also? Age also we can do, na? Age is the continuous variable.
Yes, sir.
So what the question? It is framed to doing the one-way ANOVA. We want to test. We have different designation. We have professor, associate professor, additional professor, assistant professor, senior resident, junior resident. We want to test whether age is different among these designation or not. So what do you think? Which participant will have the higher age, professor or junior or senior resident? Professors, no? So let us test this hypothesis whether our hypothesis is okay or not. Okay. So we will also go to the ANOVA. Okay. Are you seeing the ANOVA in this?
Yes.
Yes, sir.
So what ANOVA I will select? Anyone will help me?
One way ANOVA, sir.
One way ANOVA. Okay. One way ANOVA I will select. So once
Group are more than 2.
Sir, what's the difference between one-way ANOVA and ANOVA?
No, the difference is that when ANOVA is different type. No, when your aim is only to test the mean between the more than two groups, then one-way ANOVA. ANOVA is for the, suppose you are so two-way ANOVA is also there. When two variable effect you want to see it, then it will be the two-way ANOVA. So different name of the ANOVA. Someone you
Sir,
want
ANOVA is extension of t-test.
We can say that, yeah.
So now you have to help me. What variable I will select?
The designation in the
Where
grouping variables.
Where I will select the designation?
Grouping variables.
Grouping variable. Very correct. Because we want to know the difference in the age between different designations. What I will select in the dependent variable?
Age.
Age.
So age I will select it. Now you have to help me to know the it's so interpretation and the finding. After seeing this table, what do you think? Which HSO designation have the higher age?
Professor.
Is it professor? Everyone agree with me? Is it professor?
Associate professors.
Professor.
Associate
professor.
Associate and additional professor have the higher age, 48.2. Isn't it? What about the assistant professor age?
Younger, 39.
39.4.
So is it due to that small sample size? In professor, it's done only by 5.
Professor have only five in number. That's why maybe so the age are not much higher. Okay, but so maybe due to the less number, very less professor have attended the workshop. So that could be the other possibility. But anyway, whatever we are seeing the data, professor age is 46.4, associate professor 48.2, and similarly for the different designation, we are seeing the mean and standard deviation for all. Okay. So now the ANOVA will tell you whether the difference in means are significant or not between the group. What p value you can able to see with this ANOVA?
Less than 0.01.
Highly significant.
It is
Highly
significant.
significant.
It is significant. Now your second question will be, you want to see whether professor is significantly different from associate additional or not, or we can say postdoc test. Okay, whenever you do the ANOVA, we will also apply the postdoc test to know whether between the group where is the difference are existing. Okay, so how to do the postdoc test? So you have to go to the postdoc test option, and there are many postdoc tests are available, but Tukey is the very commonly we use. So I have selected the Tukey postdoc test correction, and so you will come to know the answer with this after seeing this SO output between the group comparison, which group are different or not. Okay. So if you see this one, suppose Professor H is compared with the associate and additional. What is the mean difference? It is minus 1.77. So if you minus it with 46.4 to 48.2, it will come minus 1.77. Okay. And just below this is the p-value. What is the p-value? Anyone will say associate additional compared with the professor. Age is significantly different or not? What is the p-value?
It's 0.9, not significant.
Not
significant.
It is not significant. Okay. So although we are seeing there are 1.77 year difference, but it is statistically it is not significant. So professor compared to the assistant professor, what is the mean difference in age?
7.02.
7.02. And what is the p-value?
0.011.
So professor compared to the assistant professor, statistically significant difference in the age. Okay. What
Yes,
about
sir.
the professor compared to the JRSR? What is the mean difference?
13 years and statistically significant.
Yes. And similarly, professor compared to the PhD student?
It's again 13.8 and significant.
13.8 and significant. Okay. Similarly, you can see between the group analysis whether the differences are significant or not. So this is one way ANOVA. Okay. And similarly for the homogeneity test, normality test, descriptive plot, all over you will click, and you will also same assumption what I have told you for the t-test, it will be applied here also. Okay. So time is not much, so I am not going into the detail. But one more important test I have to cover after the one-way ANOVA, which is called repeated measure of the ANOVA. So when we apply the repeated measure of the ANOVA,
The same group, but more than two observation.
paired observation more than 2 time point. If there are difference in the baseline statistics mark, second day statistics mark, and the end of the workshop marks different among the workshop participants. So more than 2 time point. Any data you are getting from this where the repeated measure of the ANOVA can be applied?
Yes, sir. That knowledge, pre statistics, second day, and end up.
So the 3 time point we have taken the statistics knowledge score and we will test. Suppose you want to another thing, suppose anyone know whether this thing different between male and female. That also you can able to know in the repeated measure of the ANOVA. Okay. So repeated measure will give you whether the different time point score are changing or not significantly. And even if there are two groups also, the change is dissimilar between these two groups. That also you can able to know in the repeated measure of the ANOVA. So let us do the repeated measure of the ANOVA. I will go to the ANOVA. Then repeated measure of the ANOVA, it is there in this our SO option. So repeated measure of the ANOVA I have selected. So this window will appear. Whenever you want to apply the repeated measure of the ANOVA, this window will appear. How many level we are having? How many time point we are having in our question?
3 time points.
3 time points. So level 1, level 2 and level 3 is given, 2 are there. So we will take 3 levels. Okay, level 1, level 2 and level 3. 3 time points are there with us to know whether SO change is significant or not. So first I will select this one, 3 time point. Then in the repeated measure of the cell, I will drag all these 3 variables. So pre-start knowledge I will select. Then SO day 2 start knowledge I will select, and end of the workshop knowledge I will select. Okay, these 3 time point I have already selected. So this will give you idea about whether the changes is significant or not, whether statistics knowledge in 3 time point are changing or not. What p-value you can able to see? This is the time point, RM factor 1. different time point statistics knowledge is changing or not. What is the p-value you can able to see with this? Is it significant or not?
Significant, sir.
So significant. So statistics knowledge is significantly changing in different time point. But let us see male and female, whether who are getting more, male are catching more or female are catching more, or statistics knowledge is in terms of the learning the statistics, males are learning faster or more or the female. So we will select between the subject factor, we will select that group variable. So group variable is gender here in our this case. So I will just dragging the gender between the subject variable. Okay. So let us see. This will give you the idea about this. So what is the p-value? RM factor 1 and gender interaction. Whether it is significant or not. What do you think?
Not significant.
Not significant?
Significant.
Participant, what this is
Not
the
significant.
gender and the time point means one gender is doing better. If this p-value is significant means one gender is doing better than other. That we will know in the descriptive statistics which gender is doing better. But what do you think? What is the p-value in this case? Is it significant or not? RM factor multiplied by gender.
Significant.
What is the p-value?
0.01.
0.010. It means it is significant. Then what do you think? Which gender will also catch more, male or female? What do you think? Not with this data, we will have to go with the postdoc test. Then we will know which group is doing better. Okay.
But sir, won't it depend on the number of the males and females?
No, number will always for the power. Okay, power means sample size. Whenever there will be class, there we will know the number, how it will affect the statistical testing. Okay, but whatever the number is available here, if it is we are getting the statistical significant difference, then we will say our number is adequate. Okay, so anyway, just we want to know which group is doing better. Okay, so let us see which group are doing better. So the postdoc test we will apply. We will apply this thing to know. We will drag in the postdoc test which group are doing better in this. So we can see this thing in a graph also. This thing you have to just drag it. So it will give you the graph. After seeing this graph, what you can able to tell? Just you. So which group is doing better? What do you think? High score means higher knowledge, higher SO gain or high marks. So which group is doing better in this case? After seeing this graph?
Females.
Everyone agree with this or some are telling male are catching more? What do you think?
But it seems females because the bar of females is high.
Bar of the female, which is the blue line is showing for the female. So female are at the lower at the baseline, isn't it? The level 1, if you are seeing when before the start of the workshop, their knowledge was less, isn't it?
Right. Yeah,
And
but they are catching up better.
they are catching very better. They are very sincere in my workshop. Okay?
Exactly. Yeah.
And you are seeing how their graph are increasing very exponential like of them, isn't it?
Correct.
But male knowledge was higher. It is also increasing, but not up to the same level of the increment as for the female, isn't it? So we can say with this interpretation, females are getting more hands-on knowledge in very sincere way. Their marks are improving much as compared to the male in this case. Okay, that we have seen with this this p-value. P-value is 0.010. So in
Sir,
this,
I have a doubt.
yes.
Sir, the p-value which you explained, there is one more p-value 0.6. Sir, I'm not able to understand which p-value to pick up. There are two tables. Table number 1 is showing 0.01 that you explained, but there is another p-value just below that also. So I'm getting confused with this p-value.
No, you need not to take this one. Okay, this is for the different purpose. This is for the main effect within the subject effect that you can able to. Okay, this p value is important.
Okay, sir.
So what are these corrections underneath Tuki, Shefi, Bonferroni?
No, this one is the big topic, so it cannot be covered with this very small so time, isn't it? So, but only thing what I want to tell you are the different method only for the correction. Tuki is the very most commonly used in our medical practice, or Bonferroni also. Okay, but depending on the nature of the various, depending on the types of the data, it changes. But Tuki and Bonferroni is good enough for our medical data. Okay.
And when there is no need for any correction, there's one option of no correction.
No, because whenever you are increasing the number of the group, no, like in the t-test we have only what? Only two groups, no, and in the pair t-test we have only two time points. So statistics tell us whenever we increase the number of the time point, or whenever we increase the number of the group, the chances for getting the false positive finding is more. Okay, means we can get more as a false positive finding. Maybe the p-value we are getting, there are chances that the false positive has so effect we can able to get. So whenever number of the group is more than 2, we need to correct, and we need to correct so that we will get the true effect. Okay, so correction is very much required whenever the number of the group is different. Okay.
Yes, sir. Okay, sir.
Any other question from the participant?
Sir, what this RM factor signifies?
RM factor is only the time. No time we have 3 time point. No pre-start workshop and the second day workshop and the end of the workshops. This RM factor is the time only. Okay, so nothing more than that. So if you are here, if you are clicking it there and you are writing time, no, so it will be visible as a time only. So it is the time. Sorry, so it got disappeared because RM factor was destroyed, but nothing. It was only the time only. 3 level, we have 3 time point. That's why we are getting the RM factor. Okay.
Sir, we have used these tests. We have used for parametric normal distribution data. What if the distribution is not normal?
When distribution is not normal, then non-parametric test, I think it is covered yesterday or not?
Tomorrow, sir.
Is it covered? No, yesterday?
It's not.
So non-parametric will be covered tomorrow.
Oh, it will be covered tomorrow. So tomorrow you will have more idea about the non-parametric test. Okay. So same software can be used for the non-parametric test also. You will go to the ANOVA and repeated measure of the ANOVA. No, just see the Friedman test. Okay, so this one you will select, and the same way you will select all these SO variable here. You can able to do the non-parametric test. Okay. And tomorrow it will be discussed in the more detail. Okay. So any question with the parametric test? Any participant want to ask any question?
सर मुझे लगता है आपकी क्लास तो पहले से एक्सपर्ट है, और जो बिल्कुल एलिमेंट्री नॉलेज रखते हैं स्टैटिस्टिक्स में उनके तो सब ऊपर इससे जा रहा है। ये रिपीटेड मेजर अनोवा आपने बताया नहीं कि कैसे होता है, क्या मतलब है इसका?
Sir, can you suggest any good statistics book?
So it is the book, written by the AIMS teacher, AIMS Statistics Department. No, so S.N. Dwivedi is the author. You can read that book, that is written keeping in the view of medical students. So so that is very simple book also. You can read that. So
Sir,
repeated.
Is it good
Yes.
for humanities subjects also, social sciences?
No, social sciences, no. That book is written keeping in a view for the medical students.
सर आपने क्या नाम बताया?
Can you post it in the WhatsApp group, the book name?
Yes.
Sir, the book name, can you post it in the WhatsApp
Can you repeat
group?
the book name?
You can write the name of the author, Medical Statistics, by S.N. Dwivedi. S.N. Dwivedi. So one participant asked me, no, I have not told the repeated measure of ANOVA. So I told you, just click the photograph of this one. So what test you have to apply? This has, so once you see this slide, it is okay, ma'am, for you. What test you want to? Repeated measure of the ANOVA is already there. Whenever you have more than 2 time point, and in this way, you just see this has, so this one. You take the picture of this one. Everything is here when we apply the repeated measure of the ANOVA. So if you have more than 2 time point, here in the group is more than 2 time point, it is observation is repeated. You will apply repeated measure of the ANOVA. So in our example, the statistics knowledge, we have taken their knowledge score before the start of the workshop in our data set. Day 2, I have taken the same information from the same individual. Then we have taken the at the end of the workshop also. So 3 time point. So in this case, repeated measure, because same observation we are taking at repeated different time point. More than 2 time point, we will apply repeated measure of the ANOVA. So better you take the picture of this slide. So this slide will give you complete idea what statistical test you will apply for.
Sir, is there any data limit for Jamovi, like a file size limit or a row limit, column limit for Jamovi?
It will also limit has, so it will be not has, so giving you has, so data for analyzing the 1 lakh data set or something like that. It is very user friendly software only for the day-to-day practice what we are using it. If you have very large data set, then better you go to the R or Stata, the larger version. Okay, but for the if your data set 1000, 2000, these are good enough for managing. I have not seen it how many number of the variable it can able to capture. But so if your variable are for the day-to-day practice, it is good enough.
सर ये स्मॉल स्केल के लिए बताया आपने, अगर मान लो 31,000 का डेटा अगर है एल्डरली पीपल का, उस पे हमको स्टैटिस्टिक्स करनी है, तो क्या ये फिजिबल होगा?
Yes, that will be yes. Also, it can cover 31,000 also. More than 1 lakh, you will go with the R software. Okay.
अच्छा, beyond the 1 lakh.
हाँ, R or SO SAS or SO you can go with the Stata also. The data also
बहुत
can give you.
एडवांस है सर, यही समझ में नहीं आ रहा हमको। तो आप तो बता दीजिएगा, अगर जैसे 72,000 पीपल का भी एल्डरली का सर्वे हुआ है IIPS की तरफ से, तो उसका एनालिसिस इसमें हो सकता है?
72,000 सब्जेक्ट का
जी
72,000 सब्जेक्ट यू हैव टू गो विद द R सॉफ्टवेयर, है ना, R सॉफ्टवेयर और
तो ये
SAS।
तो फिर ये यूजलेस है सर उसके लिए?
यूजलेस नहीं है इसका, फिर आपको एडवांस वर्जन लेना पड़ेगा तब आप कर पाएंगे। बट जितना भी पेड सॉफ्टवेयर है।
अच्छा, इसका एडवांस वर्जन भी होता है सर?
हाँ, एडवांस वर्जन आप ले सकते हैं, तो उसमें आपको हो सकता है ना।
ओके।
बट सो इफ यू नो द कोडिंग, दिस इज द सेम सॉफ्टवेयर फ्रॉम द R। आप R को यूज कर लीजिए ना, अगर आपका है सो डेटा
अरे
सेट
सर, कोडिंग कहाँ समझ में आता है, बहुत मुश्किल काम।
तो ज्यादा लार्जर डेटा सेट में तो प्रॉब्लम आएगा, क्योंकि वो सब चीजें हैं, सो यू हैव टू डील इट विद वेरी कॉस्टली नो।
Because I am working with Lassi, that's why I am asking you.
लासी के लिए तो मोस्टली सब लोग SAS में एनालिसिस करते हैं।
SAS?
हाँ, SAS में, दैट इज वेरी हाईली कॉस्टली सॉफ्टवेयर।
और SPSS में नहीं होगा?
SPSS में भी कर सकते हैं आप।
SPSS में मैडम आप ना छोटे छोटे वेरिएबल्स की स्टडी कर सकते हैं। मतलब एक साथ सारा डेटा तो नहीं कर सकते हैं, लेकिन हाँ कुछ वेरिएबल्स के साथ लेकर के उनके एनालिसिस कर सकते हैं।
हाँ, एक साथ सभी नहीं ले सकते, कुछ वेरिएबल का
जैसे आप प्रिविलेंस आप किसी पर्टिकुलर रिप्रोडक्टिव एज ग्रुप में देखना चाहते हैं, या फिर किसी पर्टिकुलर एज ग्रुप के बारे में कुछ स्टडी करना चाहते हैं, तो इसका एक सबसेट करके आप एनालिसिस कर सकते हैं।
ओके।
So any question from today's class?
सर क्लास तो
Sir,
आपकी बहुत
I have a
एक्सीलेंट है,
doubt, sir.
लेकिन
Hello.
Yes.
Thank
Can I
you
speak,
very
sir?
much for this session. Sir, I don't have any doubt from the session. I just wanted to ask you when in near future you are going to have the workshop for data analysis, your workshop.
My workshop you want to know?
Yes.
My workshop, if you want to learn the regression analysis, then I think in 26 I am speaking on regression analysis. With this same, I can also the same resilient group. I think they have invited me to speak on regression analysis.
Fine, sir. Fine, sir. Thank you.
Or that is the, I think, some different SO groups from Lucknow. I think these are the things. So you can get the information from Dr. Dharmendra.
सर आपके कोई वीडियोस वगैरह हैं जो हम उनको देख के सीख सकते हैं?
Yeah, we will share. We will share. Actually, sir has.
Sir, I have a doubt, sir.
Yes, yes.
Sir, how to see the combined effect of both the continuous and categorical variables,
Yes,
sir?
very good question. Very good question. That will you will go with the mixed model analysis. Okay. So generalized linear model. These things you have to do it for this. Oh. Generalized linear model. That also is possible, but there are some advanced analysis that also you can able to do.
Linear regression.
Generalized linear regression.
Generalized.
GLA. Okay.
Sir, how it is done?
How it is done? It cannot be so. I can teach you, but yes, you see in this Jamovi, no, if you are seeing my slide, it is in the linear models you are seeing, no, general linear model, mixed model. Are you seeing these options now?
Yes, sir. Yes, sir.
These are the way.
Rashmi, we can discuss it within the regression analysis class.
In the regression analysis.
Okay, sure, sir. Sure.
So I think for today's, I think it is sufficient because have patience. Today we have only second day, and we have more 5 days. So you will get your answers from the other sessions.
Okay, sir.
So any other question from participant?
So I think there are no more questions. So if any other, so we
Yes,
can.
more questions, sir. एक तो आपका लिंक चाहिए, कभी अगर जरूरत है हमको स्टैटिस्टिक्स पे कुछ पूछने की तो हम आपसे कंसल्ट कर सकते हैं। ऐसा कोई फोन नंबर या कोई कॉन्टैक्ट नंबर कुछ
मेल एड्रेस में लिख दे रहा हूँ अपना। आपको अगर कभी ऐसा लगे जस्ट आस्क मी, आई विल बी हैप्पी टू आंसर द क्वेश्चंस।
तो सर कहाँ से पूछेंगे?
ये मैं अपना मेल एड्रेस,
ईमेल आईडी आपके उसमें चैट बॉक्स में आ गया होगा सर का।
इन द चैट बॉक्स amit.msrachi@gmail.com।
नहीं सर, समझ में नहीं आया।
ये चैट बॉक्स में आ गया
किस
है।
तरफ दिखाई दे रहा है सर?
चैट में देखिए आप।
देखिए ना चैट बॉक्स में।
चैट बॉक्स में तो सब स्टूडेंट्स के यस नो ये जो आंसर है वही दे रखे हैं।
नहीं, आप थोड़ा अपडेट करिए ना, नीचे जाके शायद है सो
लास्ट में आइए, बिल्कुल देखिए।
मैंने बिल्कुल टॉप टू बॉटम देख लिया कहीं।
चलिए मैं शेयर कर दूंगा आपको व्हाट्सएप ग्रुप में, ठीक है?
सो नाइस।
I
आपको
think,
मुझे मेरा नंबर कैसे पता चलेगा?
मैं ग्रुप में शेयर कर दूंगा, वहां से आप सर को कांटेक्ट कर लीजिएगा। ओके, सो थैंक यू सो मच सर फॉर वेरी इंफॉर्मेटिव क्वेश्चन।
सर नो डाउट वो क्लास इज वेरी एक्सीलेंट, लेकिन मेरा लेवल शायद आपसे बहुत, मतलब आपसे क्या यस बाकी स्टूडेंट से भी बहुत बिलो है, इसलिए थोड़ा कम समझ में आ रहा था। पर वो लास्ट
depending no, because what it happened, no, because level of the all participant will not be same, no, so we have to see all. Suppose when we conduct the statistics workshop for very basic student, then there we will discuss every small thing in very detail।
नहीं सर, यू आर एब्सोल्युटली राइट, बिल्कुल ठीक है, लेकिन मेरे लिए ये शायद पता नहीं फिजिबल होगा कि नहीं। आप कह रहे हैं कि डेटा अगर लार्ज स्केल पे है तो फिर संभव कैसे होगा?
लार्ज स्केल डेटा के लिए आपको अदर है ना, जो लार्ज डेटा सेट वाली एनालिसिस वाले वर्कशॉप होते हैं ना, उस पे आपके लिए ज्यादा फ्रूटफुल होगा, क्योंकि उसके सॉफ्टवेयर भी अलग है। जैसे सर ने डॉक्टर धर्मेंद्र ने बताया आपको कि देयर आर लिमिटेशंस ऑफ द सॉफ्टवेयर, जब बहुत ज्यादा डेटा होता है ना तो ये सब।
लेकिन सर आपसे ये जमोवी सीखना तो चाहते हैं, ये एक बार में समझ में तो नहीं आएगा, क्योंकि मैं बहुत हायर एज ग्रुप में हूँ। इन बच्चों से तो बहुत, ये इन लोगों ने तो बचपन से देखा है सब कंप्यूटर ये वो, मैंने अभी सीखना शुरू किया है। तो मैं चाहूंगी कि एक बार और रिपीटेशन कहीं हो जाएगा आपके साथ, तब समझ में आएगा।
Definitely, madam, we always organize this kind of workshop, so you can join later also.
डॉक्टर धर्मेंद्र से टच में रहिएगा, इन्होंने काफी ऐसे वर्कशॉप करवाए हैं
जी,
और मैंने भी काफी क्लासेस लिए हैं यहाँ पे, तो आप रहिएगा।
नहीं सर, क्लास इज वेरी एक्सीलेंट, नो डाउट।
Thank you, madam. Thank you, and thank you so much, sir. We'll meet tomorrow.